Hey guys, it's Captain Greg. Thought we would do something a little bit different for the last class of the year. I know summertime schedules are getting tough. So you're going to have a little video that's going to take the place of the last class of the year that's going to run through a whole bunch of practice questions. And you can do this at your leisure over the next few days. Hopefully you find it helpful. First question, in what circumstances listed below do you want to use a line that will stretch slightly? Halyards, anchor road, boom fang, or sheets? Correct answer is anchor road. Here's an explanation. You want anchor roads to be able to stretch to absorb some of the shock from waves, boat movement, and things of the like. Halyards, boom fangs, sheets should all be very low stretch so that sails will stay in the position in which they are set. You are minutes from the finish line during an afternoon race and you see thunderstorms with lightning coming closer. You tell the crew to go home because they're all new dried clothes. Well, probably true. Hike out and hold on. Take off all metal, such as piercings and toe rings, or stay away from the metal objects, including shrouds, winches, and instruments. Correct answers, stay away from all the metal objects, including shrouds, winches, and instruments. You may remember we reviewed the lightning guidelines, and if you're having an imminent offshore encounter, you're going to want to first of all shorten sail well ahead of possible lightning or winds, get as many people in the cabin as possible, and avoid things like the mast and chain plates, also areas around the keel, close proximity to the engine, or directly under any of the non-grounded metal items such as winches or steering posts. You also want to avoid being directly over seacock. These are all places that lightning might seek out. If you can, avoid the cockpit. If you can't, if you have to be out there, make sure you stay low. And out of arm's reach of anything that's not necessarily grounded, which could be compass binnacles and winches and lifelines and steering posts. Within a blue section of the chart, there are the following numbers: 17, 4, 15, 10. These numbers represent depth of a rock at mean low water, soundings at mean low water in meters, soundings at mean low water in feet, or soundings at mean high water in feet. Correct answer is soundings at mean low water in feet. Or at least that's what the JSA says the right answer is. Technically, the right answer is soundings in mean lower of low water in feet. Just remember we explained the cycle, the 230-some month cycle, which the moon gets back to the exact same position that it was in synchronization with the sun being in the same position. So that whole cycle is quite long. It's about 19 years. But they average all of the low waters. So there's two low waters on average each day. So they'll average the lower of the two low waters, and that's what soundings are. So even though the test says the right answer is soundings at mean low water in feet, that's the one you want to pick. It's technically mean lower of low water in feet. In U.S. waters, the lateral system B is in effect, and when entering a port, you should keep the red buoys to your right, keep the green buoys to your left, pass red and white buoys close aboard, or keep green buoys to your right. Actually, I don't like this question very much. They say the correct answer is keep red buoys to your right, when in fact you could actually say that any of the first three are correct. So I really don't like the way the question was worded. We are trained red right returning, but having green buoys to the left is correct, as well as having the red and white close aboard, which is the safe water or center channel marker. Keeping that course close aboard is also technically a right answer, but they want the red right returning scenario, which is keeping the red buoys to the right. A boat to your port side is on a course to cross your path. The relative bearing to the other boat is numerically increasing. He will pass ahead. You should maintain course and speed, but be alert to any change. You must give way, turn to starboard and or slow down. You will pass ahead, maintain course and speed, but be alert to any change. Or he must give way, be alert to his actions, and prepare to act. The correct answer is he will pass ahead, maintain course and speed, but be alert to any change. So here's how this plays out. Let me explain. First of all, you're going to have your handy hand-bearing compass with you at all times. And I just made up a bearing. I mean, this could be anything. But let's say you take a bearing, and this guy's off your port bow, and the bearing to him is 320 degrees. You wait a few minutes, you take another bearing, and you notice that the bearing is increasing as it describes. So now the bearing is 335. And lastly, you notice the bearing has increased even more to 350. And so it's clear that he's going to cross ahead, and obviously visually you can tell that as well. I marked the greens green and red here because the boats rather, because you're the stand-on vessel, right? The other boat, assuming that he is a power boat and you are a sailboat, is a giveaway vessel. But even if it was two power boats in this scenario, he would still be the giveaway vessel. It's his responsibility with you to his right or starboard to make sure he steers clear of you. So that's how that one works out. Which VHF channel, very high frequency radio, marine, which VHF channel should be used for communicating with towing vessels? 16, 13, 68, or WX1? Well, the correct answer is channel 13. Why is that? Well, channel 13 is your ship-to-ship and ship-to-bridge communication channel. Channel 16 should only be used for emergency communication. And 68 is a working frequency. You'll find yacht clubs, race committees, and things the like working on channel 68. WX1 is one of the continuous NOAA weather briefing broadcast channels where they basically give a weather forecast, continuous observations and forecasts on a number of weather channels, and that is one of those channels. What day mark shape is used in the U.S. system voyage? Is it a triangle, an octagon, a semicircle, or a diamond? Right answer is the triangle. If you remember back to the page that we looked at that describes the various System B voyage markers, you can see it circled in the upper left-hand corner, referred to as a day mark or used in the intercoastal waterway. An example of the red is a red triangle. It is early morning during the overnight race and you are close hauled on port tack. You have been watching a powerboat approach you at a good speed about 20 degrees off your port bow. The boat is closing fast and a collision seems imminent. You should tack to ensure the powerboat sees you, hold your course because the powerboat is the giveaway vessel, start screaming nasty powerboat names, or ease sheets and steer off on a reach while blowing your horn. Correct answer, ease sheets and steer off on a reach while blowing your horn. So let's take a look at this one in a little bit more detail. So here you've got using your hand-bearing compass. You have yourself. You're a sailboat on port tack. Obviously, that wind is not exactly right. It should be a little bit more off. It'd be nice to sail that close to the wind. But you take a sight on the boat, and it bears 220. You take another sight after a period of time. The boat's closer now, but it still has the same bearing. And you get to a point where, you take a third sight, and it's still the same one. Hopefully by now it's obvious. It's been in the same place in your line of sight relative to the boat, and so it's obvious that a collision could be imminent. Now, this is a powerboat and you're a sailboat, so technically you have right-of-way. Even if you were two powerboats, technically you would have right-of-way because you are on the starboard side of this other individual, and he would be the giveaway vessel, you would be the stand-on vessel. But at some point in time, it's your responsibility to take action. And so the best action to take here would be to bear off, because you don't want to do a tack and all of a sudden get sheets caught up and things of that nature. So bear off to match or even be below his course till he passes. And the question said start blowing your horn. The technical horn signal that you should be sounding is one of danger, which is 5 short blasts. So you should have your horn out. You should be sounding 5 short blasts, and then there should be a period, and you should sound 5 short blasts again. A fathom is 9 feet, 6 feet, 12 feet, or 3 feet. Which one is it? Well, it's 6 feet. And here's an easy way to remember this one. The etymology of the word fathom is actually from an old High German word named fathom, which means outstretched arms. And so if you're an average 6-foot person, they say that from fingertip to fingertip is about the same distance as how high you are. So just remember that your outstretched arms, which is a fathom, is 6 feet. And that's a good way to remember how deep a fathom is. Bridge clearance on charts is most often based on mean high water, low tide, mean low water, or high tide. Well, the correct answer is mean high tide. And that is marked on all of the charts someplace. Right here it shows an example from chart 12354. This is not the training version, but the actual version of Eastern Long Island Sound. And right there it says heights in feet above mean high water, which makes sense. Low water would mark kind of the lowest reference. High water would mark the highest reference. So that's kind of a worst case scenario if you were. Using the practice 12354 TR chart, how many nautical miles is it from a point at latitude 41 degrees 10.2 minutes north to a point directly north at latitude 41 degrees 20.5 minutes north? Now, you'll notice that this is written a little bit differently than the way I wrote it in the course. I'm actually writing it the same way that you'll see it on the test. This is the way they write latitude and longitude. I know it's a typo, though. It's north. No, never mind. I don't see a typo. So they sometimes use longitude as just LO, but there's no degree symbol, and sometimes they omit the minute symbol. They're really not consistent in the test. But what's the correct answer? 10.3 nautical miles, 103 nautical miles, 30.7 nautical miles, or 1.3 nautical miles? And the correct answer is 10.3 nautical miles. So you could obviously go to the chart and you could do this. You could chart these 2 points and you could use your dividers to be able to measure it. But let's just do it numerically and let's think about it. Remember, 1 minute of 1 degree of latitude is equal to 1 nautical mile. So said another way, a minute, right, is equal to 1 nautical mile. So what's the difference between the 2 points that they gave us? And here in the explanations, I'll write it in the correct way. 41 degrees, 10.2 minutes north to 41 degrees, 20.5 minutes north. It's just a simple subtraction problem. And so it's 10.3 minutes difference. And since 1 minute is equal to 1 nautical mile, the answer is easy. It's 10.3 nautical miles. Not covered in the navigation course, but covered in your safety at sea course. The quick stop recovery method is based on immediately slowing the boat and turning to windward to come back to the person, immediately turning on your engine so you stop and back up to the person, stopping the boat by immediately backwinding the sail, or immediately speeding up so you can turn around and head for the victim and stop. The correct answer is immediately slowing the boat and turning to windward to come back to the person. Now, I've attended many safety at seas. I didn't attend your safety at sea on Friday. Friday you went, so I'm not sure if this is the exact way they teach the method or not, but the quick stop rescue method is a very common one, where as soon as you have a man overboard situation, you basically come up to the wind and tack. You leave the headsail trimmed as it was, so you're on port tack here. So the headsail will be trimmed down the starboard side. You leave it locked on the starboard side as you go through the tack. So you now basically have a jib backwinded, helps you turn the bow back down. Obviously, someone's watching the man overboard the whole time. You come down to a broad reach and then a jibe, which will set the boat up on the proper side. And then you basically head back up to a close reach or close hold above the man overboard person, where you ease the sails and let the leeward slippage of the boat slide down onto the man overboard person. This is considered by many to be the fastest scenario to get back to a man overboard person, particularly when going upwind, and one of the, if not the only method you learned in your safety at sea. Next question. Harnesses are to be worn under your PFD and attached to the lifelines, over your PFD and attached to the jack lines, clipped to the D-ring on your PFD and the closest metal object, or with a loop around each leg and your waist and then clipped to the lifelines. Sounds uncomfortable. The correct answer is over your PFD and attached to the jack lines. So let's look at the explanation of this one. First of all, harnesses are attached only to the jack lines because, first of all, they're secured. That's what they're there for. They're put on the boat to be able to have a point of attachment for PFDs, rather for the harnesses. They're non-metallic, and so there should be no issue with tying to something. If you're in storm conditions whatsoever, there should be nothing that's conductive, and they allow fore and aft movement. Everything should be run underneath the jack lines in terms of sheets and guys and those kinds of things, so that if you need to go from the cockpit to the forward part of the boat, you can do it all in one movement without having to disconnect your harness from the jack lines. Harnesses are worn over the life jackets because harnesses are used on the boats and PFDs are used off the boats. So you want the thing that is going to be used on the boat, the outermost layer, and really only if you end up off the boat, not attached via the jack line for whatever reason, would you need to use your life vest. And if you had the harnesses underneath your life vest, you could impede movement and perhaps even render the life vest inoperable if you end up off the boat. So the correct place is over life jackets and attached to jack lines. By the JSA and YRA of LIS rules, PFDs and harnesses must be worn: A, between sunset and sunrise; B, when the mainsail is reefed; C, when true wind speed is 25 knots or greater; D, when visibility is less than 1 nautical mile; E, all of the above; or F, A, and C only. The correct answer is all of the above. This is another one of those questions. It's a little tricky, and I don't necessarily love it because per the JSA rules for perf events, it says that all juniors and sailors and their accompanying instructors shall wear life jackets, PFDs, at all times when on deck, coming on deck, or going below. So it's a little ambiguous here. Yes, you wear it in all those conditions, but you wear it all the time. I'll take this as a second to also mention that the order that these answers, and the reason I didn't put A, B, C, or D, is the order that these are presented are totally random when you actually see the test. So this one had A, B, C, and D, but that might not necessarily be the order that those are presented in, nor for any of these multiple choice questions will that be the case. Next question. The wind has been increasing during your race, and your anemometer, which is your wind meter, has died. Maybe it's blown off, or perhaps the connection's gone, whatever the situation may be. You know you need to change sails at around 15 knots. How will you know when the wind approaches approximately that speed? The wind makes it hard to hear your crewmates. The water turns a brownish color. The lobster pot buoys are all underwater, or numerous whitecaps begin to appear. The correct answer is numerous whitecaps begin to appear. And we did not cover this in detail, but there's the Beaufort force of winds that aligns to different wind speeds. Here's some images, and the 15 knots is kind of at the upper end of the slight to moderate, and it's where you start to see a little bit of whitecaps, forming on the water. So that's when you can really start to tell that you're at 15 knots. One experience I've had, by the way, is that most people overestimate what the wind strength is. Not that that's always the case, but a lot of people say, oh my gosh, it's got to be blowing 15 to 20, when it's really probably not blowing 15 to 20. It might be blowing 12 to 14 or even a little bit less. But that's what you see if you have these kinds of wind strengths. Next question. Which navigational marks may only be lettered? And the options here are a preferred channel marker, a lighted red nun, a port side day mark, or an unlighted green can. And the right answer here is a preferred channel marker. I don't love this question because I think it's a bit ambiguous. And candidly, I could not find language anywhere in either NOAA Chart 1 or any of the NOAA things that I reviewed as I was looking at this one that says that the preferred channel markers can only be lettered. That said, they usually are. And so here's one example in the Eastern Long Island Sound chart, 6 Mile Reef, which we talked about in the course. It has a red on it. So if you're big heavy metal, as I refer to it, coming down the sound, you're going to want to be obviously to the south or leaving, coming into the sound, red 8C or 6 Mile Reef. To starboard, red right returning. But there's this other area here that's a little bit shallow, probably not enough to affect any of the, anything but the biggest boats. But it's marked by a red-green TE with the top band being the red, which says the preferred way to go to the south would be go to the south of this one, or lead that one to the right as well, because there's more distance on that side than there is between that and R8C. Next question. After a long, hot day of racing, your crewmate is complaining of headache, dizziness, nausea, and weakness, and is sweating profusely. What do you think it is, and what you should do? Again, you probably talked about this in Safety at Sea. We didn't get into any of the medical aspects, but here are your options. Too much junk food. You should stay awake in case your crewmate tosses his or hers cookies. Possibly. I think that's actually supposed to be stay away as opposed to stay awake. Hypothermia, and you should wrap your crewmate up to keep warm. Heat exhaustion, and you should fan your crewmate and apply cool, wet towels. Or it could be the flu, and you should give aspirin and lots of root beer to cool your crewmates off. Hopefully the answer is obvious that it's heat exhaustion, that you should fan your crewmate and apply cool, wet towels. You're looking to do anything you can to bring the core temperature down. If they're, if they were on deck, for example, and it's sunny, try and get them below deck. get them someplace where they get some relief from any direct sunlight and any direct heat source. When dead reckoning is a good idea to occasionally plot your position using bearing because of, first, assumed accuracy of GPS values, adjustments due to chart datum, potential errors in charted objects, or cumulative error and external forces. And the answer is cumulative error and external forces. So A, B, and C just don't make sense to me because they're all pretty accurate. If you go back, GPS is very accurate. The chart datum is accurate. There's a lot of survey information behind the charted objects. Those things are accurate. But what you do get is you get cumulative error and external forces. So let's say you're dead reckoning, and let's say your first fix is a good one. You're off only 0.02 nautical miles, which would be a very good fix. But you then base your next fix on that point, which is already 0.02 nautical miles off. And if your next fix is, say, 0.05 nautical miles off, you now might have a 0.07 nautical mile cumulative error. And that just continues to add and add and add, unless you've done a point cross-reference using pilotage or using a fixed GPS reference point or something of that nature. External forces are also difficult to judge. Current is hard to judge. Leeward slippage is hard to judge. So if you're on a boat and you're doing 180 degrees at 10 knots, but the current is setting you 90 degrees at 1 knot, so 90 degrees off, unless you're doing some supplemental trigonometry to do your plot or doing some sites, it's going to be difficult to get that charted right. And so that's why we talked about using the triangulation method to make sure that you are getting things like leeward slippage and as well as current accounted for. So that's the reason that one is the correct answer. So the next one is using practice chart 12354 TR. What quadrant is latitude 41 degrees, 15.4 minutes north, longitude 72 degrees, 20.0 minutes west located in? And the correct answer here is the upper right-hand quadrant. So this is the way they check your charting capabilities in a multiple choice test. And so how do you do this? So this is, I actually used not TR, but 12354. It's just, it's a better image to be able to take a look at this. And so they gave you the data. So you basically say, where's 41 degrees, 15.4 minutes north? And you either using, once you find that mark in off to the edges where the coordinates are listed, either using your parallel ruler or your divider to make a couple of marks at the same place. You draw a line one place. The other one is 72 degrees, 20 minutes west, and so you draw that line. That actually happens to be right down a marked longitude line, so that one's actually really easy. And the intersection of those points is the point that they're describing, and then you can say that's in the upper right-hand corner. Variation is the angular distance between a boat's meridian and true north, compass and geographic north, magnetic north and true north, or compass and true north. Again, a little bit of ambiguity here, I think, because but what they're looking for is they're looking for magnetic north and true north. That's the right answer here. And if you remember, we talked about how the magnetic pole is not exactly where the geographic pole is located. And the reminder also was that we can always go to one of the charts and look at the compass rose, and it will tell us what the variation is, right? And remember that the inner circle is magnetic, and you know that because it says right inside the inner circle, right below 0 degrees, magnetic, and the true circle is the outer circle with the compass rose with the star at 0. Reminder that points to the North Star, which is true north. It's directly above the North Pole. What are the colors of the safe watermark? Are they red and green, red and white, black and white, or international orange? So the answer they're looking for here is the red and white. And really what they're referring to as the safe watermark is the international, on the international buoy system, lateral system of B, as in Bravo, which is what we're in. The red and white is it's the center channel buoy. And so if you've got a red and white buoy, it marks the safe water, it marks the center of the channel. And the example that we gave here showed this one, the main dark black line being the preferred channel comes right from the center of that red and white buoy. Large-scale charts show large areas in small detail, small areas in great detail, large areas in great detail, or small areas with no detail. And the correct answer here is small areas in great detail. This one can be just a little confusing, so I'm going to give you just two examples. I'm going to give you, first of all, what's called a small scale chart. And a small scale chart is the small scale chart around where we are in this part of the country is the Newport to Bermuda plotting sheet. This doesn't actually show all of it. It shows kind of the northern half or the northwestern half of the plotting sheet to get from Newport down to Bermuda, which is over 600 nautical miles. And the scale, which you can see, I blew up the plotting sheet description down to the right. It's the radar Mercator projection. It says that the scale is 1 to 1,058,400 at 37 degrees, and that's 37 degrees north latitude. And so the thing to remember here is that small scale is equal to small ratio, which means things appear small. And so it's a small ratio because it's 1 to 1 million, basically, right? Another thing to think about if you want to is that 1 nautical mile is equal to about 72,913 inches. So just under 80,000 inches, just over 70,000. So in this scenario, 1 inch would be equal to about 14.5 nautical miles, which means if you're running the span of Newport to Bermuda, you'd need about 40 inches of chart, 41 inches of chart to get from Newport to Bermuda. And in fact, if you've ever seen the Newport to Bermuda chart, it's a very long and narrow chart because it's actually 4 feet long when you unroll it, and it's Newport's to your left and Bermuda's to your right, so you'd have to turn it 90 degrees. Let's take a chart we're probably more familiar with, and this is the western part of Long Island Sound, which is where Greenwich and Stamford and Norwalk and everything is located. So this is our home chart, if you will. And this is what's referred to as a large scale chart because its chart is 1 to 80,000. So remember, large scale is large ratio, which means things appear large. And so you can see how much larger Long Island Sound appears here than Long Island Sound appears in the Newport to Bermuda plotting chart. And going back to my, 1 nautical mile is equal to 72,900 inches. Guess what? At 1 to 80,000, 1 inch is equal to about 1 nautical mile. Obviously, it's not exact, and that wasn't the intention, but it's a point of reference to say, you've got, if you have something that's 5 inches apart, it's going to be about 5 nautical miles apart, and so it's referred to as a large scale chart. Next, you discover your GPS data is not correct. You're in open water away from immediate danger. You find the batteries in your backup unit are dead as well. What should you do next? So next you try to take bearings on visible marks and plot those on your chart. Place a Mayday call on channel 16. Backtrack to your last known location, or use your cell phone to call the Harbor Patrol. The last one's not a good option because your cell phone's probably not going to work. You're not going to know where your last known position is unless you've been dead reckoning. I guess you could place a Mayday call on channel 16, but it's not really a Mayday situation. It could turn into a pon-pon situation at some point in time if you can't find yourself and it's poor visibility and you're worried about getting struck by commercial ships. But the right answer is you take bearings on visible marks and plot them on your chart. So remember, we reviewed the 4 ways to determine your location, and a decreasing level of accuracy they are. Electronic, right? That's very, very accurate. You can get get to where you are within centimeters these days. But the question said it's not available to you now, right? You lost your main GPS source and your backup unit's dead. So the next most accurate thing is pilotage. So you use bearings from known objects. So if your electronics die, you go to the next one, which is pilotage. If you're out in the middle of the ocean and you didn't have opportunities to use pilotage on anything, hopefully you've been dead reckoning. And this is why I say it's always important to dead reckon from the beginning in case your electronics fail. Or in case you end up in a scenario where you can't do pilotage because you're in the middle of the sound and a quarter of a mile of visibility and you can't see any fixed marks. And then the last one is celestial. And so that's your best answer. Start doing some pilotage. Next question. The lighthouse at Plumgut on the eastern end of Long Island's North Fork is labeled FL5S Horn 64 FT17M. Complete the sentence. The lighthouse is 64 feet from the nearest rock, 64 feet above high water, can be seen from 64 feet away, or has a range of 64 feet. And the correct answer here is the lighthouse is 64 feet above high water. I have to do a mea culpa on this one. I actually, in the junior class, I think for sure said this one wrong, and that's what I get for doing conversion on the fly and not playing coast attention. I believe I mistakenly referred to this as 64 feet high, which is 17 meters high. 64 feet high is actually 19 meters high, 19 and change. And really the intention on all these things is to be able to tell you how far away you can see them. And so the capital M, which you'll see I pulled part of section P on lights from NOAA Chart 1 down the lower right-hand corner. Range is in a capital M, which stands for miles. Would have been great if they would have put NM for nautical miles, but they didn't. And height or elevation is given either in meters or feet, and that's in a lowercase m. And so these are the kinds of things you just have to be careful with when you look at charts. I've been doing this for a long time, and clearly I know that's the case, and I missed that one the day that we talked about this one. And it's so as you look at this one, Orient Point has a flashing 5-second light. It's 64 feet above elevation above high water, and it has a nominal range in nautical miles of 17 nautical miles. Now, obviously, if you were at the top of a mast of a sailboat, if someone had taken you up the rig, you're going to be able to see it further away. You're going to be able to see it, not quite so far away, but certainly further away if you're on the fly bridge of a sports fisherman versus if you're, in a dinghy. But, the concept is about 17 nautical miles, you should be able to see the light on Orient Point. You are racing and see a tug towing a barge coming out of Bridgeport, and you're not sure where the tug plans to go. To be safe, you do nothing. Call the tug on the VHF to see what its intentions are. Call a crew meeting to decide what to do. Or tack and figure the tug will work around you. What's the right answer? Well, you call the tug on the VHF to see what its intentions are. Here's the explanation. First of all, my experience is commercial captains are almost always happy to speak with you and be helpful. Occasionally you'll get somebody who's grumpy, but for the most part, I mean, it's few and far between. They're nice guys and they want to be helpful and they definitely want to be safe. As we talked about in an earlier question, you use VHF channel 13. That's the ship-to-ship communication channel. And if you don't know the tug's name, which you probably won't unless you have AIS on your boat, or if you're looking at the marine traffic app and you're someplace where you can get a cell phone signal to see what the name of the tugboat is, you could use a call sign such as, southbound tug just outside Bridgeport pushing barges. Southbound tug just outside Bridgeport pushing barges. This is, say the name of your boat. This is the sailing vessel Zuma on channel 13. And you wait for them to get back to you. And they'll get it. They'll say, well, wait a minute, I'm pushing barges and I'm just south of Bridgeport. Somebody obviously wants to know my intentions, and they will come back to you, typically with their name. So they would come back and they would say, this is the tug such and such. And then you can have the conversation on 13 about what the situation is. Say, hey, we're a sailboat, we're juniors, we're in a race, we see a couple miles off. Just want to make sure that we understand what your intentions are so we stay out of your way. It'll be a very easy conversation. If you start at race at 10:55 and finish at 16:10, how long did it take you to sail the course? Did it take you 5 hours and 15 minutes, 9 hours and 15 minutes, 555 minutes, or 5 hours and 55 minutes? Correct answer is 5 hours and 15 minutes. This is really a subtraction problem. And this can either be done mathematically or graphically. And I'm going to show both ways just because I think sometimes people struggle with this. So first of all, to subtract mathematically, what do? It's just like a simple borrowing problem in math. So it's instead of a base 10 borrowing problem, it's a base 60 borrowing problem because there's 60 minutes in an hour. But so the steps are: 1, you subtract the hours; 2, you subtract the minutes. And if you don't have enough minutes to subtract or the minutes are negative, you add 60 to the minutes and then subtract 1 from the hours. It's basically a borrowing 60 minutes from the hours process. So here are the steps. You take 1610 minus 1055. So you subtract the hours first. You take 1600 minus 1000. That gives you 600, which is 6 hours. You take then the minutes. So you take 10 minus 55. That's equal to, negative 45. It's a negative number, which means we need to borrow 1 from the hours, right? So you're going to borrow 1 hour or 100. since we're in military time. So 600 minus 100 is going to leave 500 hours, 500 hours. And then you add 60 to the minutes. So you'll take that negative 45 and add 60, and that gives you 15 minutes. And therefore, your answer is 5 hours and 15 minutes. If you want to do it graphically, you can do this. So here's the 2 times. So the first thing you do is you take the whole hours. So it's 4 and change minus 10 and change, right? It's not quite 11 o'clock, right? So you can go to the whole hour. So you're going to be all of 11 o'clock, 12 o'clock, 1 o'clock, 2 o'clock, and 3 o'clock. So that's 5 whole hours, right? And then you have to figure out the minutes on either side. So the 16:10 is 4:10 in the afternoon. So it's 10 additional minutes. And it's 5 additional minutes before you get from 10:55 to 5. So you add those two together, which gives you 15 minutes outside of the whole hours. So 5 hours and 15 minutes is the answer that way as well. 2 ways to calculate that answer to that problem. Next one, using the same practice chart, 1, 2, 3, 5, 4 again. Latitude 40 degrees, 58.8 minutes north. Longitude 72 degrees, 55.2 minutes west. What quadrant is it in? And the correct answer is the lower left or southwest section of the chart. How do we get that? So same thing again. So is you take the minutes or the latitude, 40 degrees, 58.8 minutes, and you make a mark to where that exactly is, and then you make your parallel line across using your parallel rulers. You go to 72 degrees, 55.2 minutes west, so you make the little mark to say exactly where that is, and then you draw your parallel line up and down for the line of longitude. That intersection point is the point where we're talking about, and there you go. It's the lower left-hand corner or south and west quadrant. Next question. The annual change in variation for an area can be found in a deviation table. Variation will change approximately minus 0.5 minutes west every year inside the compass rose of a chart, or variation does not change. Hopefully you all know the answer is that inside the compass rose of a chart is where you can find the annual change in variation. And it is shown right in the center. Again, I'm showing just because it's graphically better, not the TR chart, but the current version, the 2017 version of chart 12354, which is Eastern Long Island Sound, and it says right there in the center of it that the variation is 14 degrees 0 minutes west, with an annual decrease of 3 minutes per year. So if you're using this chart next year in 2018, you would use 13 degrees 57 minutes west would be what you would use as your variation number. The tide turned against you an hour ago, and the wind has died. When you hear the other boats check in with their location, you realize that your closest competitor must have anchored in order to hold their position against the tide. You decide to use your engine to make up the distance lost, to use your engine to hold position against the tide, to anchor until the tide turns or the breeze picks up, to protest them because it is illegal to have used an anchor. The correct answer is you anchor until the tide turns or the breeze picks up. I wish I could tell you that I've never anchored in a long-distance race in Long Island Sound. I would be lying. I've even anchored in around the buoys races, unfortunately. This is really a racing rules of sailing question. So the two relevant rules are, first of all, Rule 42 prohibits the use of propulsion. There are some exceptions in there, and one is to help a person or a vessel in danger. And so if you find that if you're doing a distance race and if you find another sailboat has lost somebody overboard, you may absolutely positively turn on your engine to motor to that location to help them find that person, and there will be a process for making sure that you get redress and not be disqualified. That's the last thing you're worried about. The most important thing is obviously helping the person in danger. With a couple of small exceptions, you can't use your engine. And Rule 45 it clearly allows you to anchor or to have a crew member stand on the bottom. You can actually have a crew member stand on the bottom to maintain your position. So if you're in 20 feet of water and you've got somebody really, really tall, I guess you could have them stand on the bottom. But it is actually allowed under the racing rules of sailing to stand on the bottom to not lose your position relative to where you're sailing. Navigating in the water, it is quite easy to become separated from your intended path by wind and current, to get around a hazard, by poor seamanship, or all of the above. And the answer is all of the above. I didn't give an explanation on this one. So, I mean, very quickly, right? I mean, we talked about wind and current earlier a little bit. Slippage to leeward, current, those things can be hard to calculate. If you're dead reckoning and you're going on a course, but you have to, steer around a boat that wasn't planned. Maybe less so if you're steering around a navigational buoy that marks something. I mean, that might be easier to track. But if you're a giveaway vessel and you have to take 3 or 4 minutes to deviate course, that those little minor things can be very difficult to track when you're dead reckoning. And poor seamanship, and this might not even be considered poor seamanship, but just normal, right? I mean, if you're hand steering a boat and you ever look back at what the track you've been traveling, it's never completely straight. And so, people wander a little bit to the left and they wander a little bit to the right. On average, it might be fine, but it's going to cause obviously errors. So, it's not like driving in between painted lines on a road. That's for sure. The angular difference between the true geographic pole and the magnetic pole is called resolution, variation, cross-track error, or deviation. Hopefully by now we know the answer is clearly variation. And just back to this image that we've shown a couple of times throughout the course, that the magnetic north pole and the geographic pole are not in the same place, and how that difference wherever you are impacts your compass is the variation that you see. Okay, next, the true course you have plotted from your chart is 340 degrees. The deviation on the heading that you're on is 0 degrees for your compass. The variation is 0.5 degrees west. What compass course should you steer using a magnetic compass? So your true course is 340, and you want to know what compass course you should steer. Is it 345, 335, 339, or 340? And the correct answer is 345. How did we get there? Remember our explanation from going from true to magnetic to course, and the saying, TV makes dull children. So what this basically means is that you start with your true compass course, you add or subtract variation to get to your magnetic compass course, add or subtract deviation, which gives you your course to steer. Remembering that when you're going from true to course, you add west and subtract east, and you can remember that with the mnemonic device. When starting true, west is best and east is least. And so to the right-hand side, we show the numbers from this example. They said your true compass course is 240, that the variation is 5 degrees west. So you take the true compass course, or the true course that you've plotted here, and you add, because it's west, 5 degrees, and you get 345 degrees. Magnetic compass course. They said there's no variation in this instance, so you don't add or subtract anything, and therefore your course to steer is 345. Again, using chart 12354TR, how far is it from the navigational aid RGKR, flashing 2+1, red, 6 seconds, Bell, which is on the east side of Faulkner Island, to the navigational aid RGW, FL2+1, another red 6-second flasher, this one's a gong, on the west end of Long Sand Shoal? Is it 9.9 nautical miles, 7.5, 5.2, or 6.4? And the correct answer is 7.5. Although, I say it's the correct answer when, and at one time I took a practice test and it gave me credit for it, but in the most recent, when I took this year's test, when I took the 2017 test, I was given a wrong answer for answering 7.5. And so if someone can figure out why 7.5 is the wrong answer, let me know, because here's how you do it. And what I did here is I kept the scale the same. These are two completely different places on the chart. But you'd obviously use your dividers, right? So you'd open your dividers so that they span the distance between these two marks they're talking about, and then translate that up to someplace where the scale is. And so, I mean, I did this exactly here, and you can see that it's 7.5 nautical miles. So how 7.5 nautical miles isn't correct is a bit beyond me, and I'm still looking for some clarity on that one. If anybody misses that one on the test, and that is the deciding factor from you passing or not passing, we can go back to the JSA and figure out what's going on with that question. Next question. Off the north end of Gardiner's Island is a spot on a chart of 12354TR labeled as ruins. There is also a note for danger area and a reference to note C. Locate the danger area on the chart and then locate note C. What is the danger? Is it undetonated explosives? Is it a rocky ledge? Is it a buoy G1GL, or is it fishing nets? Good question. So the answer is undetonated explosives. So the first thing you have to do is you have to find Gardiner's Island, and we talked about how, so I just took this one part of a chart. You can relax your eyes to be able to find, bigger text things that are bigger and so on and so forth. But, you find Gardiner's Island, which is between Plum Island and Montauk Point. It's the big bay that's out here, and you found the danger area. You found the ruins on the north end of it there, and you found note C. And if you go look elsewhere on the chart, that's the area we're talking about. If you go look elsewhere on the chart in the lower right-hand corner, you'll see note C. So instead of putting this right on top of the chart to make it hard to read, they put these things off to the side. And it says right here that the U.S. Naval Aircraft Gardiner's Point target in U.S. government property is prohibited to the public. So you can see that point with the triangle around it, the trapezoid shape around it, used to be naval aircraft, a target point, and fishing, trawling, or anchoring within 300 yards of this is dangerous due to the possible recovery of aircraft practice bombs containing explosives. It says it's dangerous due to live undetonated explosives. So I'm going to stay away from that personally. Depths can often be used to confirm your location by verifying the depth of low tide to the time of interest, comparing the depth with the chart for your assumed location, checking the time of high tide, or checking the depth change from high tide to low tide. The correct answer is comparing the depth with the chart for your assumed location. Tide times and tide changes aren't shown on NOAA charts, right? So what is shown is the depth at mean low of lower water. That's the chart datum, and it can be used as a reference location. If you look at your depth sounder and your depth sounder says that you're in 20 feet of water, and you're doing dead reckoning, and your dead reckoning says that you're someplace that should be 80 feet of water, you've probably got an issue. So that's what you can really find is it's another reference to be able to say where you are. In order to establish a fix by bearings, you must use at least X number of bearings. 4, 3, 2, or 1. And the correct answer, this was a little tricky, the correct answer is 2. Now, what we taught in the class was that, you actually use 3. So if I just use these 2 bearings, and you may remember this example from the class where I gave bearing from different nav aids, where those 2 lines intersect. So those are 2 lines of position. We could draw the boat right there, right? And we could have a fairly good reference point to say that's where we are. You add a third to it because it just adds accuracy. And so the plotting example we used in the course added this third line of position to be able to chart where you are. If you have 3 that intersect, then you're in really good shape. So you can't do it on 1, right? If you have 1 line of position, you could be any place around that line. You can determine where you are from 2 lines of position, and adding a third or more just builds accuracy into it. Okay, the variation is 12 degrees west. The deviation is 4 degrees east. What is the true course on a compass course of 065? Is it 049? Is it 057? Is it 073? Or is it 081? The correct answer is 057. So again, let's go back to the example that we used. So this is the opposite of TV makes dull children. This is going from course to magnetic to true, which is can dead men vote twice, is the mnemonic that captains use to be able to solve this one. And here, the formula is course steered plus or minus deviation gives you magnetic, plus or minus variation gives you true. Here you add east and subtract west, and the mnemonic device is when starting course, more east, less west is what you use. It's just the exact opposite of what we did before, right? And so 65 degrees is your course steered. You add the variation of 4 degrees because it's east, and so you're adding east in this scenario. That gets you to a magnetic compass course of 69 degrees. You then subtract your 12 degrees of west variation, which gives you a true compass course of 57. If you had gone the other way, if you had true of 57 to get to 65, it would be 57 plus 12 would be 69 minus 4 would be 65. But you can see, since we're going from course to true, this is the approach that you take. The scope used in normal conditions for an anchor road made of rope is 3-to-1, 5-to-1, 7-to-1, or 10-to-1. The answer they're looking for is 7-to-1. I say the answers they're looking for because they really didn't give you enough information, right? They really didn't tell you the type of bottom that you're anchoring in, the type of road that's being used. Is it all rope? Is it rope with 10 feet of chain on the end? They didn't tell you what kind of anchor. Is it a Bruce? Is it a fluke? There's a lot of factors that go into this. And by the way, many sources would show greater guidelines for anchoring with a rope road in normal conditions than 7-to-1. But 7-to-1 is the answer they're looking for. And this is just a couple of examples, that would align up to where they are, is you'd want a scope of 3-to-1 if you were doing a temporary anchoring. If it was calm to light conditions and maybe you weren't going to stay overnight, if it was a day anchor, you might do 5-to-1, 7-to-1 in normal conditions. And then if it's really heavy conditions, you might do 10-to-1. First of all, what does that actually mean? What is a 3-to-1 or a 5-to-1 or a 7-to-1? Let's say the water depth is 10 feet. If the water depth is 10 feet, you'd want to put 30 feet of rope out. If it's 3-to-1, you'd want to put 70 feet of rope out in normal conditions if it is if it's a 7-to-1 that you're targeting. And so you'd want to have marks on your anchor road. You'd want to know that you're in 10 feet of water. It's important, by the way, to know where you are in the tide cycle. So if it's low tide and it's 10 feet, maybe it's going to be 15 feet at high tide. And so your 7-to-1 would go from putting out 7 feet to, all of a sudden putting out over 100 feet. And that can make, a big difference in what your holding power is going to be of these anchors. Next one, using the practice chart 12354TR, what's the latitude and longitude of the Nav 8R 2PG, flashing red 4-second bell located near Orient Point? And I won't read through all the options, but there you'll see those options. And the right answer is 41 degrees, 10.6 minutes north by 72 degrees, 13.1 minutes west. So how do we do this? This is the way they do this on the test. You'll see I kind of split the chart in half here so that there's the actual 2PG, which I just circled, but then I kept the scale the same and showed the lower part. And so, basically, again, what you're going to do is you're going to use your parallel rulers. You're going to put your parallel ruler next to a line of latitude. You're going to extend that parallel ruler up to be able to go out across to the side, and then read where that point touches the scale. And it's 41 degrees, 10, and then go up 0.6. So it's 41 degrees, 10.6 north. And you're going to do the same thing to get your longitude. You're going to put your parallel rulers parallel to either the side of the chart or one of the lines of longitude. Remember, longitude lines all go through the poles. They run through north and south. And you're going to work your way over then to make those parallel rulers go through the mark R2PG and see where that goes down to the bottom. And that's going to be 10, 11, 12, 13.1 is what it looks like. Was that what the answer was? Yep, 13.1. Oh, I probably have it here if I hit one more time. There you go, 72 degrees, 13.1 minutes west. The 180th meridian of longitude is commonly known as the local meridian, international date line, prime vertical, or prime meridian. And if you remember, we discussed this one, it's the international date line. So that is the point where a new day starts, because it is a time zone of UTC minus 12. So when it's 12 noon in Greenwich, it is the beginning of a new day at the 180th meridian, which is also known as the international date line. If you were a polar bear, at which line of latitude would you most likely be found? 1 degree north, 10 degrees south, or 66 degrees north? And the answer is 66 degrees north. Why is that? Let's just look. Remember, lines of latitude, they're run lateral. They're ladders. Latitude is like a ladder you have to climb up. So you have to climb up the ladder, right? I use the Jimmy Buffett song. Let's cousin in Miami, let's take it down south, boys, down south to those little latitudes. And so the line of 0 degrees latitude is the equator. So you can see I just pointed to where 1 degree north would be. 10 degrees south is here on this Google Math image, and you can see where 66 degrees north would be, way up top, up in the Arctic Circle, as a matter of fact, or right at the Arctic Circle. And hopefully it's clear that polar bears would live there and not close to the equator. Okay, using the practice chart, 1, 2, 3, 5, 4 TR, what's the light sequence for the fixed nav, a light on Stratford Shoal? Is it flashing 2.1 R 6 seconds, flashing G 4 seconds, GC1 with no light, or flashing 5 seconds? And the answer is flashing 5 seconds. And if you go look on the chart at Stratford Shoal, which I blew up here, it says that right there, it says flashing 5 seconds, which means it's a 5-second period of white light. Remember, it's white if no colors given. If you look at R2, it says FL red, FLR. But if there's no color given, it's a white light. 60 feet is the elevation, and its nominal range is 13 nautical miles from which the light is visible. So you can see Stratford Shoal from 13 nautical miles away. The most important reason for pre-planning a trip is, once you know your destination, you can steer directly towards it. To tell you the time you'll arrive at your destination, it shows what boats are near you, or it shows any hazards along the way. And hopefully it's obvious that that is the correct question. Because you won't steer directly towards your course, because there's going to be things in the way. It's not going to give you any idea of time. You might give you an idea of how long it will take if you plot each leg and you plot the speed that you're going to travel on each leg. It's certainly not going to do anything to tell you about the boats that are along the way. Marine compasses with no deviation will point to geographic north, magnetic north, true north, or grid north. The answer, obviously, magnetic north. At the start of a race, the race committee displays the direction to the weather mark as 070M, magnetic. The course from the weather mark back to the committee boat is 180 degrees, 250 degrees, 170 degrees, or 260 degrees. If it's obvious, the right answer is 250 degrees. Let's just take a look at this one and explain that. This is what we call a reciprocal heading. So 70 degrees, you can add or subtract 180. It doesn't matter. If you add 180, it means you don't have to go around past north to figure it out. So if you add 180, 70 plus 180 is 250. If we do it graphically, here's a line pointing to 70 degrees. If we flip that line around and extend it back to the other side of the compass, you can see it pointing at 250. That's how you figure the reciprocal heading. The sailboat you are racing on is 42 feet long, and the running lights you are required to use after dusk are a bow light, which is red to port, green to starboard, the white light on the transom, and the all-around white light at the top of the mast. Next is the combination red on your right and green on your left, bow light only. Next is a flashlight you shine on the mainsail about halfway up. And the next option is only the masthead tricolor light that has red showing to port, green to starboard, and white astern. Your 42-foot sailboat, what's the right answer? It's only the masthead tricolor light that has red showing to port, green to starboard, and white astern. This is really a Colreg question. You may have covered this in Safety at Sea. I'll pull up this graphic just so you can see. First of all, the first one that talks about the all-around white light at the top of the mast, it's not that one, because the only time there's an all-around white light at the top of the mast is when you are anchored. The other option that you could have on a sailboat of this size, so the second boat over is the one that it described. It said under sail, you can either have the tricolor light at the top, or you can have the bicolor light at the bottom with a stern light. Either one of those are acceptable for a boat under sail. If you're under motor, you have to have the bow red and green lights and the stern light, and what's called a steaming light, which is about 2/3 of the way up the mast. So that's what a sailboat looks like. A couple of the sailboats that I raced on in the past, by the way, used to have a switch where you could switch from having the tricolor mast up at the top to the bicolor light with the stern light at the bottom. And we used to flip those sometimes through the middle of the night so that our competitors would have a harder time tracking us. Either one of them is acceptable. In the set of answers that this one had, it didn't describe the bicolor light with the stern light. That wasn't an option, so the only one that was sufficient was the red and green up top with the white light. Next one, a few years ago, a 400-foot supertanker ran aground off the coast of Old Saybrook. The exact location was 41 degrees, 13.8 minutes north, 72 degrees, 32.2 minutes west. Find the position on chart 12354 and pick the best explanation of why it ran aground. Here are the options. It must have hit an uncharted ledge or obstruction because the chart shows plenty of deep water where they hit. Next one is it was on the wrong side of R8A and hit Long Sand Shoal. The next one is the buoy RGTE marks a rock that it hit. And the last option is it must have cut too close to Duck Island and did not observe buoy 8. What's the right answer? It was on the wrong side of R8A and it hit Long Sand Shoal. So let's go figure that out from the coordinates. So let's take the map that they gave us here. Again, I'm using not the training map, but the updated version. So let's take the coordinates they gave us. So the first coordinate was 41 degrees, 13.8 minutes north. I'm going to put a little bit of a tick there exactly where that is, and then draw. I did this in a slightly different sequence, sorry. So then I put 72 degrees, 23.2 minutes west up top as the longitude, and I put a little mark on that. And then use your parallel rulers to extend both of those. First of all, the line of latitude, extend that across so it's parallel to the edge of the charts and to the other latitude lines, and then you extend your 72 degrees, 23.2 down using your parallel rulers. Those are going to intersect someplace, which we'll put a circle around, and guess where that is? Right on top of Long Sand Shoal. And so since Long Sand Shoal is only 5 or 6 feet deep at low tide, rest assured that is something a 400-foot tanker is going to hit. Luckily it's soft, and I hope there wasn't too much damage or injury. Next question. You are a watch captain at the helm at 0430. It's been an exhausting cold race with lots of sail changes, rainy weather, and too much junk food. The crew is all crashed out on the rail and below. The wind's building. You'll soon need to make another sail change using all hands. So what do you decide to do? Only wake up a couple of the guys or a couple of the crew and try to manage shorthanded in bad weather. Wake everyone up and get ready early so that their skill and judgment will be better for the maneuver. Just skip the sail change and hope that the wind goes back to what it was previously, or let everyone sleep until the last possible moment knowing how tired you are. And I hope it's clear the answer is that you wake everyone up early and you get them ready so that their skills and judgments, they'll have time to adjust, they'll have time to adjust the light, they'll have time to get their senses about them. People have collectively decided to go on sailboat races, and you're working together as a crew, and somebody may be tired, they may not be feeling good, but it's one of the great experiences about it. You got to suck it up and get done what needs to get done. You're told to check the stuffing box for leaks, so you go look around the drain of the ice box, around the propeller shaft, where the speedometer goes through the hull, or around the base of the head. We didn't talk about this one in the nav class. I don't know if you talked about it in safety at sea, but it's in every one of the practice and the actual test I took, so I'd put it in here. It's around the propeller shaft. That area is called the stuffing box. And just so you know, I mean, this is an example of the shaft. Basically, what a stuffing box is, it's a big screw, and inside that they put, so it's called stuffing. It's almost like a rope. It's like rings of rope. A square rope is the best way for me to describe it. There'll be 3, 4, 5 rings of square rope that are in there, and then as you tighten this screw around it, it basically compresses the rope together. And so the object of a stuffing box, and there are newer types of stuffing boxes, but a lot of sailboats still have, especially older ones, have the rope-based stuffing boxes. If you don't have the stuffing box nut tight enough, there's not going to be enough pressure and it will leak a little bit. If you have it too tight, there's going to be no water that gets into it, and then it can actually burn out and create a severe leak. And so it's a bit of a science. You're supposed to have 1 drip of water about every minute is what's supposed to come in from a properly tightened stuffing box. There you go. You look at the chart and figure you're 2 miles from the finish, assuming your speed stays at 3 knots. Yes, this is Long Island Sound. That's the way the question's written on the test. How long will it take you to get there? 30 minutes, 20 minutes, 60 minutes, or 40 minutes? And the correct answer is 40 minutes. Remember, we talked about the distance, speed, time triangle, and that can be used to help solve this problem. You're trying to solve for time, and so time is equal to distance divided by speed. So it's told us that our distance is 2 nautical miles and that our speed is 3 knots, and therefore 2 nautical miles at 3 nautical miles per hour is going to take you, time-wise, 2/3 of an hour. So you take 2/3 of an hour times 60 minutes, and that gives you 40 minutes. And that's how you solve this one. Preferred channel buoys indicate the preferred channel to transit by, whether they're odd or even numbers, what the buoy light pattern is, the color of the top band, and a white light. You know the answer is the color of the top band. So going one more time back to the visual voyage guide, is circled in the middle there is a preferred channel marker. You could go to the either side of that red over green, but remember, red right returning. The preferred channel is to use the top band as the color, which is red. So the preferred channel means that you would leave that red over green on your starboard side. Compass deviation is caused by twisting the electric wires near the compass, the magnetic attraction of the Earth, magnetic influences aboard the boat, or erratic steering. And the answer is magnetic influences aboard the boat. We didn't get into the details around this. I did do some stuff on the whiteboard, but you know, there's a lot of things that cause magnetic deviation on a boat. Engines being just one of them. Engines are like kind of the biggest, most magnetically charged piece of equipment that's on a boat. And so, depending on what direction the engine is relative to where you're steering, that's why deviation is not always the same. This shows how a compass needle is going to divert away from magnetic north and have some pull from the engine. And so, hopefully, if the boat has been well built and the compass binnacle has been installed correctly, you might not have an issue with this, but you're certainly going to have an issue with it if you're using a hand-bearing compass and you're standing in some place that's, highly magnetically charged from one side to the other. So that is deviation. As you sail downwind against a flood current that continues to strengthen, would you expect the seas to get rougher or smoother, assuming the wind remains the same? So are they going to stay the same? Are they going to get smoother, or are they going to get rougher? And the answer is they're going to get rougher. And why are they going to get rougher? Well, let's take a look at what happens when wind and tide oppose each other and are going the same direction. So the top one is the scenario that they described. So you're sailing downwind against a flood tide. So you're going left to right, if you will, in this scenario, because the wind is pushing you left to right, but the tide is coming right to left or coming directly onto your bow, and the tide is building. So the speed of the tide against the wind, the differential between the white and the tin, is going to continue to increase, which is going to make those waves sharper, steeper, and therefore rougher. If you are going the opposite direction, so if you had the wind behind you, so in the bottom one you're going right to left, and if the tide was increasing, it would just continue to decrease the differential between the two, and therefore it would be calm and getting calmer. So that's the answer to that. A line of position is an electronic position using Loran, a good way to know exactly where you are. A position line showing the bearing to or from a fixed mark or object, or all of the above. And clearly we know that this is a position line showing the bearing to or from a fixed mark or object. And we had discussed this during the course, and I actually showed this slide earlier. You know, the bearing from these fixed marks, so one from the Saybrook Breakwater Lighthouse, one from R8A, which our tanker ran aground inside of, and one from R8, which is over at the eastern end of Long Sand Shoal. You know, we have lines of position from each one of those, and with bearings and degrees magnetic. And that's the end of it. Good luck on your test, everyone. It's been fun working with you. We'll be available to help anyone who needs help before the test or after, whenever you run across your navigational challenges. Again, best of luck.